Take this time and welcome everyone to another SOX lecture. Thank you so much for being here. Today we are having a lecture on cybersecurity of operational technology with Johan de Wit. Thank you so much for being here today. Johan de Wit works for Siemens Smart Infrastructure Technical Officer Enterprise Security and is involved in global Siemens portfolio development. He owns a master's degree in security science and recently successfully defended his PhD at Delft Technical University, where he explored the characteristics of security risk assessments. He is a member of various expert communities and advisory boards like the Dutch National Cybersecurity Center, ACES, Information Security Forum, Overseas Security Advisory Board. He is a regular speaker at conferences and universities and publishes papers and articles. Thank you so much again for being here today, and I'll pass you the word.
Yeah, thank you very much. Well, the recent PhD was, in the meantime, a year ago. So I guess it's still recent, given my my age. Then a year is pretty recent still, but you might think it's quite some time ago. Yeah. Well, thank you for inviting me again, I must say. So this is the second year that I present this topic. So I'm happy that I was asked again to tell you about a lovely topic that's close to my heart and close to my company's heart, which is the security of operational technology, OT. And I will come back to that later on. Let's dive into the topic, and I'll start making it a little bit bigger. So the current time we are in the middle of this transformation of digitalization, as you may call it. And if you look what exactly that is that we connect everything to everything, and that has some a lot of opportunities, but also some vulnerabilities that we come up with. And actually, if we connect everything to everything, we connect the real world to the virtual world and make a kind of cyber physical systems. That's what we currently do, or maybe we have done it already, and we are not always aware that we have done it. This brings us a lot of benefits, a lot of new business models, a lot of prosperity, a lot of well-being as well, because we use all these cyber physical systems around us. From social media, but also maybe the heating of your house, etc. All cyber physical things, or the elevator. The downside is that we are completely dependent on that, and I will refer to some of the reports in the Netherlands. So this is a report of the Dutch scientific organization advising the government. This is a report of 2021, preparing for digital disruption. And there they stated, so it's only 4 years ago, so the awareness is not really that high, but it states that we are more and more depending on this digital technology and this cyber physical technology. That means, and here it states again, we connect the physical world to the digital world. And we connect cybersecurity to safety, and I will come back to that later on when I explain what OT systems actually are. But so cybersecurity is not something that will affect maybe only your bank account, but it could affect your health and well-being. It could cause accidents if it doesn't work properly, or if it's affected by a cyber threat. And it's no longer theoretical, and it's not the case. We don't have to question ourselves if it will happen. It already happens, and if it doesn't happen, if you haven't experienced it before, you will in the future. It's not a matter of if you will experience, but when you will experience it. And we are all in the middle of well, I don't have to go too deep in the geopolitics that we are currently in the whole turmoil that the whole world is in. But there are a lot of cyber threats out there, and it's cyberspace, or the cyber physical systems are kind of weaponized nowadays. So there are serious threats to our critical infrastructure, which is the foundation of our society currently. And as said, this is pretty new stuff. So we will talk about a little about these. What can we do about it? I will take you through some regulations that are coming up that will help us being more resilient. And that will be the main part of the presentation, mainly the regulations that are about cybersecurity of OT systems as well. This is each year the Dutch government or the Dutch National Cybersecurity Center makes a report, and I think it's available in English as well, on the cybersecurity in the Netherlands. And in the report of 2015, so 10 years ago, it stated that society will stop if digital systems would break down or malfunction, and no analog alternatives were available. I had at the time already some doubts. 2019, similar report, it stated that almost all the analog alternatives were no longer available. So in 4 years' time, the Dutch government from 2016 to 2016 to 2019, 15 to 19, 4 years' time, they changed their opinion from having an idea that there might be an analog alternative to that there are actually no analog alternatives anymore. And especially in current societies, think about your the financial system is almost entirely depending on digital infrastructure. Now you could argue that you could pay with cash, but a lot of these shops and businesses, especially in Europe, already have cash registers that simply will not work if there's no internet connection. They cannot book it. So although you might have cash and you could pay with cash, the cash register cannot be used without internet. So even this all kind of financial system is completely depending on the digital domain. So we have a challenge or problem, and what are we going to do about it? Now, before we go there, briefly introduce myself as was already done by Emma, by the way. He kind of summarized who I am. So I work for Siemens Smart Infrastructure, and we secure mainly buildings, so smart buildings, smart sites, smart cities, and we have all kinds of solutions and services to secure buildings and sites. So think about physical access control with badges or something, video surveillance, alarm receiving centers. So we build control rooms for buildings, for campuses, for cities, where you collect all the data. And this is exactly some cyber physical system. So a lot of the detectors are out there in collecting information about the physical environment, and they transfer that to an IT environment. That's what I do for Siemens. As said, I got my PhD last year and studied risk assessments. And besides all that, I'm part of several communities of practice, expert communities, and business communities, both in the Netherlands and international. A few words on Siemens, and don't worry, it will not be a commercial break. Siemens consists of several legal entities. So you have Siemens Healthineers. They do healthcare systems, so all the scanners and MRIs. We have Siemens Energy, building power plants and renewable energy. And you have the Siemens Core, so the original Siemens Core, and I'm part of this Siemens Core. And that core consists of digital industries, doing process automation systems, smart infrastructure, my part, where we do both the infrastructure itself, but also smart buildings. And you have mobility, where we do trains, etc., and train systems, tunnel systems, everything with transportation. Just to give you an idea, smart infrastructure. So my group is about 70,000 employees globally, and we do about 15 billion annually on turnover. So this is a part of the global Siemens organization. Within smart infrastructure, I'm the security guy. So I'm working on physical and cybersecurity. And nowadays, these two are interlinked very heavily. So you cannot talk about one or the other without connecting them, connecting the dots, so to say. So back to the question, what are we going to do about it? Because we seem to have a problem. Now, this problem or this vulnerability is not exactly new. And in the European Union, it started around 2013, 12 years ago, with the cybersecurity strategy. Now, what does this say? It contains a lot of threat information, but also something on how do we make our society future proof or future safe. And you see also on the threat side, you see here the hybrid threats. And that is something that as we have connected the digital and physical world into these cyber physical systems, also the threats collide into cyber threats and physical threats, and they go together. So a lot of the attacks that we see and a lot of the threats that we see are a combination of maybe a physical intrusion into a building to not to steal anything, but to have network access from the building to the central organization or to the central data warehouses. So you see these kind of hybrid threat combinations of hybrid threats. This European security strategy was the foundation for a whole bunch of other regulations that came up afterwards. And there are quite a few that during the time were set up and implemented in the European Union. Now, this is very Europe-centric, I understand. But on the other hand, all these regulations need to be followed by all the organizations that work in Europe as well. So it's not only for Europe. These regulations turned out to be extended to a lot of organizations around the world. So the organizations that want to do business in Europe, for instance, had to the GDPR might be known to you, General Data Privacy Regulations. That's a European regulation. But if you want to do business in Europe, then you have to comply to that regulation. And so it's with all the others as well. So a lot of global organizations are facing these kind of regulations as well. I won't go through all of them. I want to check out two, the Cyber Resilience Act and the NIS2, so the Network Infrastructure Security number 2. And I'll go a little bit deeper into those two. Starting with the NIS and the NIS2. So the NIS2 means that there already was an NIS1, so the Network and Infrastructure Security Directive. It was already there in the European Union since 2016 and implemented in 2018. Now there's an update from that, so the NIS2 is the update that was the European Commission approved that in 2023, and it should be in place since October last year. Now that's postponed in a lot of the countries because the scope of the NIS2 kind of extended to so much that a lot of government agencies simply could not implement it in time because it's a huge amount of extra work that they come up with, and I'll come to that in a second. These regulations will be applicable to all the countries of the European Union. What's generally the idea? I took a nice graph from KPMG. It's not only about securing yourself, but it's mainly about securing society. As society is depending on the digital systems need to be secure. That's the whole idea, that by securing the digital part of the critical infrastructure, we actually secure society. One thing that is very prominent here in at least Western countries. I'm not really sure about South Africa how the percentage there is, but in the European countries, 85% of the critical infrastructure is privately owned. 85% is privately owned. So if the government wants these private organizations to enhance their security, they can friendly ask them to do so. Usually that doesn't help or doesn't help enough. So that's why they have all these regulations in place, so they kind of enforce the organizations to make it secure. Not to help the organization itself, but to help secure the society that these organizations are serving. Just to give you an idea, the financial system, and probably in South Africa as well, is completely privately owned. So the banks are privately owned, insurance companies are privately owned. Energy sector is partly privately owned, so a lot of energy production is privately owned. Healthcare system is largely privately owned. Public transport, at least in Europe, is for a big part privately owned. So there are a lot of these kind of sectors that are actually run by private organizations. So it's 85%. Now, to help them or to force them to get more cyber secure, we have this NIS2. I see someone raise his hand. I'm not sure whether we take this question now or later on.
We typically the questions later towards the end, the verbal ones, but
Okay.
if you prefer, we can take them intermittently.
We can take them now if they are connected to what I'm telling now. That would make sense, I guess.
Okay. Are the just checking the questions that we have, are they directly connected to what we're discussing now, or is it a general question that can wait towards the end? If so, you can put your hand down and then bring it up later. Otherwise, if it's directly relevant now, you can keep your hand up, and then Emma can unmute you for you to ask your question. Yeah.
Okay. Habrithi, if you want to ask your question, you can. I've unmuted you, so you can turn on your mic, please.
Sorry, it's a technical error. I don't aim to ask question.
Okay. Okay, then I will just continue. The difference between the NIS and the NIS2. First part is the scope of this regulation, and the NIS2, the NIS was 2016, NIS2 was 2023, so 7 years apart. And what we learned is the original scope and the definition of what critical infrastructure is changed quite a bit. And you see the bottom on the bottom right, and that entire block was added to the critical infrastructure list. So the government actually came to the conclusion that critical infrastructure is a much broader part of society than they originally planned. So a lot of extra sectors now became formally critical infrastructure, like, for example, the healthcare sector. That wasn't a part of critical infrastructure definition in the NIS, but it is now. That means for all the healthcare institutions in Europe that they have to comply to this regulation. But it also means that all the governments in Europe will have to audit all these organizations, whether they comply to the regulations or not. And that is a huge amount of organizations that are added to the scope. And that's the reason why some of the governments, and one of them is the Netherlands, they simply could not keep up because they have to extend and grow their organization quite substantially, because the amount of organizations they have to audit is grown tremendously. So that's one part of what has changed. And again, although in South Africa you don't have to comply to these regulations directly, it gives you quite some insight, because the issue in South Africa will be more or less the same. So you also have critical infrastructure that needs to, where you need to make sure that they are safe and keep your society running. So the elements and the why we do this in Europe is also applicable to other countries like South Africa. Some additional changes from the NIS to the NIS2, and there are two that I want to pick out. One is that it's not only the organizations themselves, so the organization that is critical infrastructure needs to comply, but those organizations need to make sure that their entire supply chain is complying as well. So take the example of Siemens. Siemens itself, we are not a critical infrastructure organization, so we are not part of this definition. But all the systems that we deliver, whether it's healthcare, whether it's transportation, whether it's buildings or sites, whether it's energy and energy production, all our customers, or the majority of our customers, they are critical infrastructure. So although we don't have to comply to the NIS2, our customers will demand us because they have to secure their supply chain. So they will demand us to become more secure and to deliver secure goods and services. Now, obviously, we already did, but this is a growing issue for a lot of organizations that hadn't secured themselves up front. Second thing that is changed into the NIS2, which is highly important as well, is the liability part. The upper management of organizations is personally liable for the security measures taken. So of course, they cannot prevent everything. So they will not be blamed if an organization is hacked, but they will be blamed if an organization is hacked and they refuse to take enough measures or they refuse to comply to the regulations. Then they are personally liable. That is particularly written in because sometimes what we learned from the NIS1 is that a lot of top management didn't want to invest into cybersecurity enough. Obviously, they understand that that's important, but you could argue whether they invest enough. So with this in hand, their personal liability, if they don't do enough, there's some extra pressure on them to allow the organization to make their processes more cyber secure. Now, what does it mean for organizations? A few things. Obviously, and obvious ones, and I'm not sure this is not the first lecture you get in your cyber school, so a lot of this must sound familiar to you all. It starts with identifying your critical assets. You have to have a recovery and disaster recovery plan. You have to do security assessments on a regular basis, so check if everything still is up to date. And there's a lot of dynamics into cyber threats, so you have to keep thinking, asking yourself whether you still have enough controls in place. Number 4, that's an obvious one, of course. So you have to update your software, but a lot of organizations still don't do that properly, especially in the OT domain, which we will cover shortly. Training is a part. Now, you are a perfect example of already of that you train yourself, which is a very good thing, and a lot of more employees need to be trained on cybersecurity. So in a lot of cases in the safety domain, especially in Europe, and I think in South Africa as well, a lot of employees are trained to work safely. So wear a safety helmet or safety shoes and work in a safe environment, etc. Something similar needs to happen for cybersecurity to make all the employees aware that there's cybersecurity risks that they need to take into account. And number 6 is monitoring. Monitoring your network, looking for suspicious things, strange things. That could be malicious, or it could be just by incident, could be something going wrong. So these are some of the things that are in the NIS2 regulation that companies and organizations need to comply with, need to implement in their organization. Now, these are kind of standard things for cybersecurity. So it's nothing new. For a lot of organizations, this is nothing new. What is new is that now the government will come check whether you did this right, or whether the government thinks you did enough on this. So that is the change that we now have with the NIS2. Now, I mentioned OT quite a bit, so operational technology, and that is kind of the a different perspective than the IT, so information technology, two different things. So it raises the question, what exactly is operational technology, OT? And we go a little bit back in time in the industrial revolution that we had. So in the industry 2.0, we start electrifying stuff, and industry 3.0, we start automating production processes. So this, when we had electricity, we could build automated processes with electrical components. But to be able to do that, we need to automate that with controllers, and one of them is PLCs, programmable logic controllers. These kind of things are, you can find them everywhere. So I mentioned already the elevator. The elevator is controlled by a PLC somewhere in the equipment room, but also on our barrier. But the same counts for tunnels. There are automation layers in your energy networks, practically everywhere, and opening and closing a bridge, all kinds of things. But also production processes in factories are full of these kind of automation devices. That's industry 3.0. Now, what happened over time is that we started connecting these systems. Originally, these were autonomous systems, so they were kind of standalone systems. They sometimes had computing power with some kind of the old-fashioned PCs that were giving them computing power, but there simply was no network connection other than a local network connection. There was no internet at the time. And what we did is we start connecting these up to internet and to other networks. And that is when both the boom came for industry 4.0, when we connected this all, but also the vulnerabilities came. Because we were connecting the formerly kind of isolated OT systems, we can open them up to first the IT networks in organization, and after that we open them up to the internet for a large part. And sometimes that happened without people knowing. So a lot of these OT systems suddenly got exposed on the internet without anyone being aware of that, because they just simply had maybe one of the benefits for some OT system could be that you could control it via a mobile device. It would be easy. So what we've seen here in the Netherlands, we obviously have a lot of water and a lot of bridges. That some of the operators of a bridge, they needed to go to the bridge to open and close it. Now, by having this automation system connected to the internet, at some point in time, they could open it and close it from any location. So they didn't have to go to the bridge to open it. Of course, there are all kinds of security measures in place, like barriers should be closing and traffic lights should be red, etc. And maybe they have a camera view on that, but then they could remotely open and close it. And this is, of course, this is a very good thing, make their whole operation much more efficient. But on the other hand, if you don't secure that connectivity, and at some parts they didn't, other people could break into this system and suddenly started opening, closing bridges. And that's obviously something that you do not want. So people started using this connectivity between OT and IT without being fully aware of what the risks of this connectivity were. And that's something that we still struggle with today. And as you've seen in the reports, these reports where I started off with, so prepare for disruption, for example, was 2021. So it's not that long ago that we started being aware of what the implications of this connectivity is. OT systems, operational technology. Now there's a lot of names, and I collected a few. There are kind of subsets. So sometimes it's called industrial control systems or the industrial automation and control systems. The downside of that naming was, and years ago when I was visiting a big bank in the Netherlands, and I talked about and I asked them, do you have ICS systems, so industrial control systems? And the people at the bank said, well, of course not. We're not industry, we're a bank. Obviously, they have a lot of these industrial control systems, for example, in their data centers running. So the energy supply of a data center is running through industrial control systems. The ventilation and mainly cooling for data centers is automated with industrial control systems. But they were simply not aware because the naming industrial implied some kind of factory. And they said, well, we're a bank, so it doesn't apply to us. That's why we rather use this overarching terminology of operational technology. It kind of encompasses all the different subsets of systems. So let's look a little bit at the threats and controls that we put in place. I'm not really sure, but I guess you've seen these three. So IT security is usually focusing on three domains. So availability, so you want to have your cybersecurity in place to make sure that your systems are available for the amount of time that you need them. Confidentiality, of course, privacy is a part of that. So you want to have the information, you keep that inside, or you keep that confidential. And integrity. Integrity means that the data that you have, the information that you have, that you can be sure that that's correct and that's accurate, so that you don't have the information of a week ago if it's maybe updated at the same time. So cybersecurity or IT security is protecting these three elements, and that's something that you probably will have in different other lectures as well. These three elements will come into play. Now, for operational technology, we need to add a fourth one to this, and that is safety. And you saw that at the start, you saw that already in the report. Now, as OT security is a cyber physical system, so take the example of a bridge. So the automation of this bridge, of course, it should be available because you want to open and close the bridge. And if you open and close it, your security systems or your safety systems, so the barriers blocking traffic, should be closed before it opens. So they should be available. If something goes wrong and you have an emergency stop button, this stop button should be available real time as well. Otherwise, you have a safety issue. Now, this is completely different than with an IT system, where you don't have your information available for half an hour. You cannot access your email. Probably nobody dies. It can be harmful, it can cost money, it can stop your business from running, but it doesn't affect the health and well-being of people. In OT systems, it usually does have effect on health and safety issues. So this fourth element is essential for OT security systems. And usually as an IT security professional, and even if you, I hope if you all become IT security professionals, we need quite a bit. So I hope that you all find a good job in IT security. Please remember this, as an IT security professional, they usually focus on these three elements and they tend to forget the fourth one, this safety element. OT security is quite different from IT security. You must be aware that you cannot simply, for example, do an update of your software. Because suppose that you do a software update of this bridge example, and you update all your automation components of the bridge. How do you make sure that it completely works? In an IT environment, you probably know pretty soon that something is not working correctly, and then you roll back your update. If you would notice that something on the bridge is not working, you might have a safety issue at hand. So you don't want to have that just kind of trial by error. You want to make sure upfront that your system is completely doing what it should do, and all your safety measures are still functioning after the update. This means that if you do a software upgrade for a bridge, for an automation system of a bridge, that you normally completely test the bridge. So you open and close it and you test all the different features, and especially the safety features. So is the barrier to block the traffic, is that indeed first closed before the bridge opens? A simple example. All these safety features should be checked before you start operating it. This makes, obviously, a software update much more complicated and much more costly, I would say. You need much more resources for this testing of such an entire system than it is in an IT environment. There are a few more differences between IT systems and OT systems. I just listed a few and can pick and choose a few out of them. So we all know that IT systems don't last that long, and after a few years you have a new laptop, or you have new software versions running on them, or you need a new laptop because there's a new software version coming on your laptop. Now OT systems, and take again this bridge example, these systems will be there for 20, 30, 40 years. Because no one will change that, because it's a very costly operation if you have to close down your bridge, rip everything out and build something new in. So these systems have a very long lifespan. This means that in a lot of these OT environments, production processes, water plants, bridges, elevators, etc., there are still components from last century, so more than 20 years old. A lot of them are not up to the cybersecurity standards of today, because 25 years ago, the world looked a lot different, and these systems might not even be connected to the internet at the time. Now they are. So we have to deal with all these legacy systems. I already mentioned the second one. So in OT systems, we have to be very high available, and we have to be real time. So if you push the emergency stop button, you must be sure that it stops immediately and not after 20 seconds or something, or maybe it doesn't function for 15 minutes. So that's something that simply is not accepted, cannot be accepted in an OT environment. It might be in an IT system that you say, well, someone has no access to the main data source for 15 minutes. Okay, then I just have to drink a coffee and wait for 15 minutes. You cannot have that in an OT system. Physical security, usually in IT systems, it's pretty high. We all know that we need to secure data centers and data rooms. The OT systems, I take again, for example, the bridge. The equipment is positioned all over the bridge. So there are sensors and networks all over the bridge, and they're in our technical rooms that might be secured with a key usually, but not as high secure as a data center is. I think these are the main ones, and maybe this one, the security awareness, and that's my next slide. This is 2015 a report, so that's 10 years ago, but unfortunately it's still usually still the case. What TNO, Dutch Scientific Organization, researched at the time, that the industrial control systems, so now we would call it OT systems, and IT systems are managed by two different organizations. So you have your IT department, and probably you all will be working in an IT department in the future. You have your IT department, but the OT systems usually are in a production. So they are in the general management of organizations. There are two different organizations. And the production people, so responsible for the production of a plant, or maybe the operation of a bridge, they don't think that their OT system has IT risks in it, because they are feeling that, well, I'm controlling a bridge, I'm operating a bridge, I'm not operating an IT system that's controlling a bridge. On the other hand, the IT people The IT people, like yourselves, hopefully in the future, or maybe already, they don't understand the differences between IT and OT. And I hope this lecture will help you understand these kind of differences between IT and OT and make you aware of them and make you, I hope this awareness will help you to understand and reach out to the OT people in your organization and to help them make their systems more secure. Because the ICS people, the OT people, they don't really have a good common understanding of cybersecurity risks like you do. They didn't have this education that you currently are following, for example. So you have to help them understanding the cybersecurity risks of their system. Another report of the Dutch National Cybersecurity Center, also a few years back, but unfortunately still the case. So they call it Industrial Control Systems, ICS SCADA. You saw the definitions that I mentioned previously. That also is the building management systems and the security systems. Usually they're not in the scope of the IT security policies. So IT security people are simply not aware that there's OT systems where they need to think about as well, or they could think about as well. They think that the operational people will do that, and the operational people, like I said in the previous slide, they're simply not aware. As the OT systems usually have this lifespan of 20 to 30 years, and in these 20 or 30 years, they get migrated, parts are extended, parts disappear, there's some new parts built in, etc. So there's a lot of things going on in these OT systems, so it's very hard to get an overview of what is actually installed. Usually a lot of organizations don't exactly know what they have, what is installed in place and what is in place. And what we know from the IT world, where you can simply have your asset management discovering all the components in your network, in the OT world, as some of these systems are over 20 years old, they simply cannot be discovered automatically. So it's very hard to get an overview of what exactly is installed. And this makes an assessment of the risk that's very difficult. Just to make you aware. Now, how are we going to secure then these OT systems? Well, a lot similar to IT systems, to be honest. We have these defense in depth or layers of defense kind of principles, and you know obviously the people, process, and technology. So that these three elements need to be secured. And like with IT systems, we secure them from the outside in. So it starts with the physical access of site security. So you want your systems to be installed in secure places. So you maybe have a fence or a locked door of access control, or maybe it's monitored by cameras or by control room, or even guards walking around. So you want to secure your site and the locations of your OT systems. And the second part is network. You need to secure the network and network access. And the third part is the system itself should be secured as well. Now you might be familiar in the meantime with the ISO standards, and especially for IT security, the ISO 27000. Now for OT security, there's a different one, and a different standard. And that's the IEC 62443. It's a global standard, and this global standard specifically focuses on OT systems. And it consists of various parts. Part 1 is a general part, and then from the bottom up, part 4 is about components. So it's there's a lot of in the standard a lot of regulations and recommendations how to make secure components. So the components, the automation components, for example. So going back to the bridge has a lot of sensors that sensor if the bridge is open or closed, for example. But also the automation components, getting in that information from the sensors, analyzing it, transferring it, and send it to electric devices that will open or close the bridge or lock it, for example. So part 4 is about these components. How do you make secure components? Now you might have secure components, but if you have someone installing it, a system integrator, that isn't using the security settings that the components have. So for example, these components come with a factory or transport password. If the system integrator or the people that install that component on site don't change the standard passwords, and that happens a lot, then obviously everybody would try to use the standard factory passwords, and in a lot of cases they still function. So it's not about having a secure, not only about having a secure component, but you have to have an organization that will install it secure as well. So the part number 3 of this norm is about the organization that make a solution out of all these individual components. Finally, part number 2, if you would have secure components that are installed securely, you can still use it very insecurely. So if for example, the asset owner using, or the operators will not change their password regularly, or have difficult passwords, or write their passwords down on sticky notes which they put on their machine, then obviously the components are secure, the system as a whole is secure, but it's not used in a secure way. So all these 3 elements are part of this IEC standard. And as if we are the supplier of the components, so obviously we comply to number 4. Usually we are also the system integrator, so we comply to part 3 and 4. But we also mention, and we train and educate our end customers to be aware of section 2, which is about how to use such a system securely. And I think that's a very important part of this standard, that it covers everything from product to installation to actual use. Now, not all the systems have the same level of security, so this standard identifies 4 security levels, from maybe largely insecure, so SL1, to very secure, which is SL4. And so you can classify, and that's up to the end user as well. You can classify your system in a certain security level, and then you can take your controls and your measures accordingly. Now, this could mean, for example, in my building environment, we do, for example, HVAC systems, so cooling and ventilation for buildings. In a regular office building, this will have a low security level. Obviously, it will be very inconvenient in the building if it doesn't work, especially in your area. In our area, it might be cold. In your area, it might be too hot to work inside, but it's not really a security level. But it would be for example, a data center where your systems would go down. Or think of a hospital where the temperature, especially in the operating areas where they operate people, that is a very tight set of bandwidth where the temperature and the ventilation needs to work in. If it doesn't fit, then this room should be closed. Otherwise, the patient will become endangered. So the same system in an office building can have a different security level than similar components in a hospital, for example, just to that you understand how these systems work. That means for us that although the components are the same, how we set up a solution, so that was the second part of the standard, might be completely different because we have to face a different security level in different situations. Siemens, just to give you an example, Siemens has implemented this IEC standard into the entire organization. And that means that we do 2 things. We do this product development, so that's the process on top. So we develop products and sell them, but we also do make these solutions. So we are the system integrator of these products. So that's the bottom one. What I just told you, this is the smallest part, but as the life cycle is 20 years, these arrows would extend far beyond the screen. because usually making a product, defining it, and building it is a few years, but the life cycle when it's installed is up to 30 years. So that's a long way ahead. So these arrows should be very long. Now what we did, we took the standard, and for every step in the process, we have defined which parts of the standard are applicable to the process, and it affects everybody. So it affects people who are developing products, but it also affects people who are ordering products from suppliers. It affects how we design systems. So for the engineers, it affects how we commission systems in the field. So the field engineers need to comply. So everything, every single process and every single person in the Siemens organization needs to take parts of these standards into their working process. And this means that this is not something that someone in the corner does. So cybersecurity, oh, that's that guy that's sitting in the corner. Or maybe if you finished this education, that it might be you. It's not just you doing this. No, it's something that the entire organization have to work with, like with safety. Safety is not up to the safety manager. No, it's up to everybody working safely. So and that's the same with this standard. Now to keep this, to organize this and to govern this, we have a governance organization in Siemens as well, taking care that all our processes, all our internal processes are aligned with this IEC standard. Just an example from us. There are obviously a lot of other organizations who do something similar. Now, one thing left. I promised you 2 regulations to go a little bit deeper. First one was the NRS2, and the other one was the Cyber Resilience Act. That's coming up soon. As said, the NRS2 is applicable to critical infrastructure and their supply chain. The Cyber Resilience Act is applicable to everybody that builds or sells hardware components with a hardware with a digital component, as they call it, in the EU. So it complies, more or less everybody who sells something nowadays, all the components and even toys have digital components built in them. So it's applicable to a large variety of different products that are sold inside the EU. And as said, a lot of these products are manufactured outside of the EU and imported. So it could easily be that if a business in South Africa produces, I don't know, toy radios for the EU, that they have to comply to the Cyber Resilience Act to be able to sell it in the EU. So again, this is kind of regulation that will spread out over the world. Everybody who does business with EU will have to look into this. Now, what does it mean for manufacturers? The first thing, and that's something that you probably heard before as well, is secure by design. So it's not something you design a product and afterwards you think, okay, what do we need to do to make it secure? No, that's not the way it should be. You should think about from the start about how to make your product secure and not bolt it on afterwards. That's something that we do at Siemens as well. You saw the processes. When we start designing a product or a software for the product, then part of the development team is a security architect already. So they think about all the different threats to make it secure from the start and not just afterwards. Second thing is that we have to document, and manufacturers have to document all the risks that they are taking into account. So afterwards, you can see whether they had the entire vulnerability list or threat list, what their products are tested and built against. So you have kind of transparency of how secure these products are made. Following
sorry, Sorry,
Yeah,
Johan, I'm just giving you a shout out that there are 5 minutes left and a few questions, so just to keep in mind.
Okay, then I will speed up. Then you can read these afterwards. One thing that's important for this regulation, I'm almost there, by the way, the Cyber Resilience Act. There will be a lot of products which have a kind of low risk posture. They will require a self-assessment of the manufacturer. You can imagine that all the manufacturers will say, well, it's secure anyway. Now, on the right side, you see the products that are critical class 1 or class 2. Those are usually the products that are installed in the critical infrastructure, and they have to have a higher standard. So it's either tested by the organization itself, or it's even a third-party assessment that they need to comply to. So it depends a little bit on the product itself, how the application is and how the risk is. For us at Siemens, the majority of our products will be class 1 or class 2, so we will have a lot of work to do to test them. We already do that, so we are practically ready already for this regulation that will come in 2027, but there's still some things we need to add to that. And here are some examples. Now to summarize, and I'll quickly go through. We had IT and OT, and you have different standards here. So you have the ISO 27000, that's IT. You have the IEC standard, this IEC 62443, that's OT standard. And we have regulations coming up, the CRA, that's for the supply chain. And we have the NRS2 for, let's say, the demand side of things. So how this is kind of covering the entire critical infrastructure at least. And that this is my last slide. It means that thinking about security is not only about security, but it will be also about more and more about compliance, being compliant to regulations, because they will be enforced and there will be penalties and liabilities that come with it. That was it from me. I hope this helps you in getting a broader perspective on IT security and adding OT security to your basket of knowledge and skills. I hope you enjoyed it, and I'm open for the questions, Emma.
Okay, let's start off perhaps with some written questions that were written throughout. The first one being, the interconnectedness of OT with IT places the IT systems at risk, especially due to the patching requirement. Is segmentation the best control? What other controls do you suggest?
Segmentation is definitely a good control. Having said that, what we often see is that these IT and OT environments are separated, but then the OT environment is not controlled or monitored, because that's not a part of the IT monitoring system. So if you separate them, please make sure that you also monitor the operating environment, because there will be IT components as well in the OT environment. So we still use PCs and servers and databases, etc. But there are IT components there that you need to manage too.
Okay, thank you. The next question is, what sectors or specific OT systems would you say are most at risk of cyber attacks? In terms of cybersecurity governance at a bigger level, what role should a national government play in trying to mitigate these risks and enhance operational resilience for critical infrastructure? Are there any best practices to recommend in these fields?
There are a lot of questions in one, I would say. Well, to start with the government part, so in the European Union, the governments are helped with these regulations. So they give a framework, and they make let's say a level playing field for all the different organizations working in the critical infrastructure. The focus of the government is the critical infrastructure, because then if that's affected, then parts of the society will not work. So regulation and use of standards is kind of a best practice that we see in Europe to make sure that organizations have their cybersecurity up to date. That was at least one of the questions. There were, I guess, 2 more that I didn't answer. Can you help me out?
Yeah, so one, then there was kind of well, that one led into trying to mitigate these risks and enhance operational resilience for critical infrastructure. So if there are any practices to recommend in these fields.
They are kind of similar to what you would learn in the other lectures, probably about IT security. So all you saw one on my slide with the 6 bullet points on the NAS2, which are kind of general topics, and I would say best practice for securing both IT and OT security systems. So I think all the controls that you would put in place for an IT system would work for an OT system as well, taking into account the differences that I explained as well.
Okay, thank you so much. We are at a time. I can take one more voice, like, how to say it, in-person question, if you would like that. Otherwise, we can move on to Mentimeter. Is that okay?
Yep.
Okay. Ogidan, I just unmuted you. If you can unmute yourself and ask your question, that'd be great. Thank you.
Good afternoon. Good afternoon. My question is that what are the critical dependencies of OT systems on other IT systems? Let me come back again. What are the critical dependencies of OT systems on other IT systems? Thank you.
There are a lot, to be honest. I think almost any OT system nowadays uses IT components, so IT networks, IT servers, like I said, databases. They use Microsoft software as well, usually. They have PCs connected to it, so a lot of IT components in the OT environment. Most critical is that if you would consider your OT environment, including all these IT components as a separate environment, and a lot of IT departments do that, so that's on the other side of my firewall, and I don't want to be bothered with it because I don't understand what these guys are doing, and it's not monitored. So the biggest risk is that you have IT components that are simply not managed. They're not patched, they're not updated, they're not monitored, etc. So that is, I think, the biggest challenge for this interconnectivity of IT and OT. Now, if you would connect your OT systems directly into your entire IT environment, you have maybe a attack factor that someone using the IT connection of an OT system, take for example a security system, a security camera. Nowadays, a security camera that's usually outside, or a few of them are hanging outside of your building or on your fence, so easy to reach. They usually have a network connection. If you can use that network connection to come into your building, into your IT system via the and you could reach the IT department, then you have easy is not the right word, but you have access to your IT system. So that's a different attack factor that could take place if you connect it directly. So this separation of systems would be good as long as you monitor it.
Okay, thank you so much, Johan, and thank you so much for your lecture here today and being here with us. And if for anyone who would like to stay, of course, we're past our time, but I will run the Mentimeter. Otherwise, thank you again for being here, and we wish you a great day.
My pleasure, and I wish all the candidates a very good education, and hope they all succeed in getting their certificates. Thank you.
Thank you so much. Bye.
Okay. Bye bye.
Bye bye. Screen. Okay, everyone. I will now be sharing my screen. Let me know if you can see it. All right, can everyone see my screen? Elton?
Yep, looks good.
All right, great. So if everyone can join me at menti.com and use code 4461014. Thank you. Okay, so the first question is, what is the greatest cybersecurity risk to OT environments? I'll give you guys about another minute just to let everyone join, read the question, read through the options. Okay, for the sake of time, I'm going to go forward, but it seems like the consensus is unanimous, human error, and that is the correct answer. Moving on. What is the most common attack vector for industrial control systems? Physical sabotage, supply chain compromise, phishing and social media engineering, or insider threats? All right. Seems like the response is unanimous-ish. Yep, it's correct. Phishing and social engineering. Which cybersecurity framework is commonly used to secure OT environments? A, NIST Cybersecurity Framework, B, OWASP Top 10, C, ISO 901, D, SOC 2. Okay, seems like more or less there is a unanimity in the answer. Indeed, it is NIST Cybersecurity Framework. Moving on, in an OT environment, what is the primary risk associated with legacy systems? A, they require excessive electricity. B, they often lack built-in security features. C, they are too expensive to upgrade. And D, they do not require regular maintenance. All right, wow, this is pretty unanimous. Oh, someone wrote they require excessive electricity. A few for they do not require regular maintenance. But the correct answer is they often lack built-in security features, right? Okay, what is the main purpose of a demilitarized zone in OT networks? A, to act as a firewall replacement. B, to separate IT and OT networks for security purposes. C, to store critical operational data. And D, to provide a backup power source. Right? And to separate IT and OT networks for security purposes is indeed the correct answer. 6, what is the function of an intrusion detection system, IDS, in the OT environment? A, it blocks all unauthorized access. B, it prevents all cyber attacks. C, it monitors network traffic for anomalies and threats. And D, it replaces firewalls. Okay, and the answer is it monitors network traffic for anomalies and threats. Moving on, what is the best way to protect OT networks from ransomware attacks? A, implement strong segmentation and backups. B, use only antivirus software. C, disable all external network connections. Or D, rely solely on firewalls. Okay. The answer is indeed implement strong segmentation and backup. Moving on, why is patching difficult in OT environments? A, OT systems often require continuous uptime. B, patches are usually unnecessary for industrial control systems. C, OT devices automatically update themselves. D, patching is not relevant to OT cybersecurity. Okay. And the correct answer is A. Moving on. What role does multi-factor authentication play in OT security? A, it replaces passwords entirely. It ensures that only authorized users can access critical systems. It encrypts network traffic. It prevents malware and funk. Okay, B is the correct answer. And moving on to our last question for the day. What is the primary difference between IT and OT cybersecurity? A, IT focuses on protecting data while OT focuses on securing physical processes. B, OT is concerned with network security while IT focuses on industrial automation. C, IT and OT have identical cybersecurity concerns. D, OT cybersecurity is less important than IT cybersecurity. All right, well, it seems pretty unanimous, and it is, in fact, IT focuses on protecting data while OT focuses on securing physical processes. Okay, let me stop sharing the screen. Okay. I want to thank all of you for being here today. We had a short day with just one lesson, but tomorrow we are back with 2 lessons in the afternoon. Thank you so much for always participating and coming to lectures. It really, really means a lot. And I'm wishing you all a great day.